This is Jack Jackson. We're back with the last of our series of review exercises from Unit 1. So let's start with review exercise 21 and we'll go to the end of the set. So what do the following situations say about the skewness of a data set? Situation 1, the mean equals the median. Or, next situation, the mean is greater than median. Or the last situation, the mean is less than median. What do these three things say about the skewness? Work this out. Come back when you've got an answer. Press pause now. Well, if the distribution is symmetric, the mean and median will equal each other. So if the mean and median are very close to each other, the distribution will be approximately symmetric. If the mean is greater than the median, the distribution has some positive skewness. If the mean is less than the median, the distribution has some negative skewness or skewed left. So in general, the longer tail to one side will have the effect of dragging the mean in that direction, while it will have a much smaller effect, or maybe even not as much, or maybe even no effect on the median. So if the data set is highly skewed, then there will be a significant difference between the mean and median. In this case, the median is often the better measure of central tendency. However, it is good practice to report both the mean and the median of a distribution, thus giving a better description of the center and also giving some indication of the shape as well, as we see from this exercise. Exercise 22. Suppose that we are told that the quartiles of a data set are 15, 45, 52, 55, and 63. How do we determine which data values will be outliers? Given only this information, do we know if there are any low outliers? How about high outliers? Press pause now. Well, if we want to determine an outlier, we see if it falls outside what are called the fences. So the interquartile range, IQR, is Q3 minus Q1. So in that case, it is 55 minus 45, that's 10. 1.5 times that would be 1.5 times 10 is 15. So the lower fence is Q1 minus 1.5 IQR, or 45 minus 15, which would be 30. So any value below 30 is an outlier. We know that the minimum of 15 is below that 30, so there's at least one low outlier at 15. However, we don't know if there might be other outliers or even how many data points we have even at 15. But we do know there's at least one outlier on the low side at the minimum of 15. The upper fence, similarly, is found by doing Q3 plus 1.5 times the interquartile range. So that's 55 plus 15 is 70. The maximum is 63, which is less than 70, so we know for sure there is no outlier on the right side or upper side of this data. Describe when you should use the following types of graphical displays: dot plot, broken line graph, for example, a time series, a bar graph, like maybe a histogram, a scatter plot, box and whiskers plot, and a pie chart. Press pause now. Well, a dot plot is useful with at least ordinal data and displays all the data values, giving a visual indication of shape, center, spread, and outliers. A broken line graph, such as a time series, is used when the data is interval or ratio and it emphasizes changes, particularly, say, maybe changes over time, as in a time series. A bar graph, for example, a histogram, can be used with any level of data, especially when the height of the bar is the frequency or relative frequency. It does a good job of showing relative sizes of the categories and the shape. A scatter plot is used for bivariate data, where we're graphing dots for the ordered pairs. Okay, so when your data is essentially ordered pairs of data. A box and whiskers plot, or just box plot for short, is used with quantitative data to summarize measures of relative standing, and it gives a visual indication of center, spread, shape, and outliers. I like box plots a lot. They really can show you pretty quickly a lot of information about the distribution. A pie chart is used with nominal data to emphasize parts of the whole or relative frequencies. Pie charts should be used very sparingly. You should only really use them when the number of categories is fairly small, certainly less than 10, better off even smaller than that. And when you never use a 3D pie chart, always use a 2D pie chart. And you have to should only use it with a categorical data. If the data has an inherent order, you're much better off with a bar graph. Compare and contrast the following two histograms. Press pause now. Well, we notice that we see in the left, we see that first of all, for distribution A, we see the center is less. It's centered at 5, which is actually the mean, median, and the mode is 5. Whereas the mean, median, and mode of data set B is 10. So data B has the higher center. Data set A is less variable. Data set B is more variable. So data set B has a higher variability, that is a higher standard deviation, a higher range, a higher interquartile range, a higher variance than A. Smaller standard deviation on A. As far as basic shape, they're the same. They're both perfectly symmetric. So in both cases, the mean and median are the same and the skewness is 0. And in fact, the mode is the same as the mean and median as well. Compare and contrast the following unmodified box plots for data sets A, B, and C. Press pause now. Well, let's talk about some of these different characteristics. Let's talk about center. Well, we see that the red one, B, the one in the middle, is the highest center, and the lowest is A, with C being somewhere in the middle. We can tell that from the median here being much higher than this median here. So the median on B is higher than the median for C, which in turn is higher than the median for A. Specifically, we can read those, put numbers with that, read them off the scale. We see that the median for B is 90. Go down to 85 for the median for C, and you're down to 70 for the median for A. What about outliers? Well, A and C will not have any outliers. I can kind of see that by the length of this box, 1.5 times that, and to the left of here is going to put you below this minimum, and 1.5 times the length of that box will put you above the maximum here. Similarly for the A, but not true for B. If we did 1.5 times this box and went below this, we'd have a fence in here somewhere, and definitely the minimum is below that. So there's B has an outlier. It wasn't marked as an outlier here because this is an unmodified box plot. So it'd be better to use a modified box plot, have the outlier marked here. But definitely it has an outlier on the low end, at least one. How about shape? Well, C is symmetric or really close to it. I mean, these two parts of this box are the same. This and this are about the same length. So that is a symmetric distribution. Okay. A is also roughly symmetric. It might be skewed just a tiny bit to the right, but it's roughly symmetric. B, on the other hand, is definitely skewed to the left. Not only does it have this outlier, within the box, you can definitely see the median is toward the top of the box. This upper part of the whisker here is definitely much smaller than the lower whisker. So it's definitely skewed to the left. What about variability? Well, if you're looking at just range, the range is biggest on set B, but we also had an outlier there, so that's a little deceiving. If you look at it, it's really the most consistent, at least on the upper half. The interquartile range is the smallest, and in fact, the whole upper 3/4 of it are spread out only within 10, which is much higher here. It's almost 18, I guess, across here, and even more across here. And then the interquartile range, let's see, this one is 7. This for B. Set C has an interquartile range of 10. That's the length of this box. Q3 minus Q1, or the length of that box, is 20 for the interquartile range for A. So if we look at that, we can see B is the most consistent in spite of the fact that it does have an outlier down here. Review exercise 26. Statistics for annual salaries for employees at a company were reported at $567,000 for the mean and $76,456 for the median. What can we say about salaries of the company? If only one of these numbers was reported, which would give a better picture of the company's salary distribution? Press pause now. Well, since the mean is so much higher than the median, then the salaries are heavily skewed to the right. So this is likely due to at least one outlier on the upper end. So probably somebody at the top, like the CEO, possibly several people at the top, a few, in the upper management have outlying salaries which are extremely higher than the rest of the employees. In this case, the median gives us a much better measure of center of the distribution of salaries and would be the best to report if you're only reporting one measure of center. So then in this case, if you reported that as the average salary, that may be a very deceiving kind of a statistic. And reporting these two together, however, is good because then it shows you that probably most people are centered around this amount of 76,000, and with a few people probably making a whole bunch more, bringing that mean up. Okay, compare and contrast the formulas for sample standard deviation and population standard deviation. Explain why there's a slight difference in the two formulas. Press pause. Well, here are the two formulas. On the left, we have the formula for population standard deviation, which is x sub k minus mu squared, and then average those. Sum from k equals 1 to capital N, divided by capital N. And then let's do a square root of that to get the population standard deviation. So as with all formulas that do parameters like this, sigma, population standard deviation, when we find the corresponding sample statistic, we just sort of change the letters for the most part. So the sigma is replaced by S to be the sample standard deviation. The population mean, mu, is replaced by the sample mean, x bar. The sample size, N, in the top here, the sum, the population size, capital N, is replaced by the sample size, little n. But instead of dividing by little n, which would be the natural thing to do, we change it up a little bit. We put an n minus 1. Now, why do we do that? This corrects for a bias. And the reason we have this is samples have a tendency to be less variable than the full population. So if we had left this with a little n here instead of n minus 1, we would have gotten a sample standard deviation that does not accurately reflect the population standard deviation. So to make the sample variance an unbiased estimator for the population variance, we make the adjustment by putting n minus 1 there. Notice putting the n minus 1 there has the effect of making that whole fraction a little bit larger, which is what we want to do. So we get that. And the big picture, of course, is that these are both measures of variability or spread. In fact, standard deviation is probably the most used measure of variability. Well, I believe that completes our review exercises. If you can do all of these exercises, then you should be in good shape for the practice test and the exam. I do have a couple of other videos following this in the playlist. These can be considered optional for my class. They do, however, show me doing some problems actually from my math lab and show me writing out things instead of actually having prepared slides. And you might find those useful as well for some extra problems to do. But this is the end of the unit as far as the required material. So good luck with the exam, studying for the practice test. If you have these down, you got the practice test down, and then the exam will be very similar to that as well. So you should be ready for your exam once you've mastered these review exercises.